Assalamualaikum and hello everyone. We are from group 64A, group 2, and my name is SYUHAIDAH binti ABDUL.
My name is NURFARAH NATASHA binti Muhammad FAIZAL.
My name is YASMIN binti HISHAM.
My name is NURUL GHAZALI.
And I am SITI YUSRA binti RIZAL.
For this experiment, we have chosen Sungai Langat as our water source. In this study, we will analyze several important water quality parameters, which are
Biochemical oxygen demand, sour oxygen demand, chemical oxygen demand,
Harmonica nitrogen, total suspended solid.
stability, and also pH. Stay tuned for our video.
And don't forget,
Safety first!
pH. Firstly, fill the beaker with water sample and then rinse the probe with deionized water. After rinsing the probe with deionized water, put the probe in the beaker that contains the solution. Do not let the probe touch the stir bar bottom or the side of the container. Stir the sample at a slow to moderate rate. And then push the read button. A progress bar is shown. When the measurement is stable, the log icon is shown. After taking the reading, rinse the probe with deionized water.
First, prepare the blank sample and the water sample by filling the sample cell with 10 ml of deionized water and 10 ml of the water sample. Clean the blank sample and insert the sample cell in the instrument cell, and then we will close the lid. Press the I/O to turn the instrument on and set the instrument. Press read and the display will show the value of the turbidity. Next, we will record the turbidity after the lamp symbol turns off. Repeat the same steps with this water sample set.
First, we shake the water sample water gently to ensure the contents are well mixed, and then pour the water sample into a clean beaker. And by using a clean pipette, we need to measure exactly 2 ml of the water sample and then transfer the 2 ml of water sample carefully into the COD vial. Immediately seal the vial tightly with its cap to avoid evaporations and contaminations, and then we shake the vial thoroughly for a few seconds to ensure the chemical reactions are well mixed. For the blank sample, pour some distilled water into a separate beaker, and again, by using a new pipette, measure 2 ml of distilled water and add it into another COD vial. Seal the blank vial with its cap and shake it well to ensure uniform mixing, just as with the sample vial. And then we label both vials clearly as blank and water sample. Then we need to preheat the COD reactor at 150 degrees Celsius, and then we insert the COD vials for 2 hours at temperature of 150 degrees Celsius, and we press start. After 2 hours, we take out the COD vials and put it on the cooling rack for 10 minutes to cool it down. To determine the COD readings, first we need to wipe the blank sample vial with tissue and insert it into the spectrophotometer and set it to 0. Then we wipe the water sample vial, insert the vial into the spectrophotometer and press read. Then we repeat steps for 3 times to obtain the average reading. Finally, we can turn off the spectrophotometer.
For biochemical oxygen demand, we need to prepare the dilution water. Firstly, add the distilled water into the beaker, and then prepare the dilution water by adding 1 ml each of phosphate buffer, magnesium sulfate solution, calcium chloride solution, and ferric chloride solution. And then aerate the solution for approximately 1 hour to reach oxygen saturation.
Next, fill in the BOD bottle with 50 ml of the water sample and 250 ml of dilution water for DO0 and DO5. For the blank sample, fill in the BOD bottle with 300 ml of dilution water and carefully insert the stopper in each bottle to prevent trapped air bubbles.
Then label the DO0, DO5 and blank sample with stickers.
Put the BOD bottle for DO5 in the incubator for 5 days.
Before reading the DO0 sample, rinse the pot with the ionized water. Put the prop in a beaker that contains the solution. Do not let the prop touch the stir bar, bottom or side of the container. And then remove the air bubble from under the prop tip. Stir the sample at a slow to moderate rate. When the measurement is stable, the log icon is shown. Record the data and rinse the pot with the ionized water. After 5 days, take the reading for DO5 and repeat the step from the DO0.
First, prepare the sample and blank sample by pouring 10 ml of water sample and deionized water in each sample cell. Start the spectrophotometer and insert code, which is 630 for suspended solid. Clean the blank sample cell with a towel or tissue to remove any dust. Insert the blank sample cell into the cell holder and push 0. Clean the pipette sample cell. Insert the pipette sample into the cell holder and push read. Then, the results show in obtained value of the sample.
Fill the deionized water into the beaker as a blank sample. Fill the river water into the beaker as a water sample. First, fill a mixing cylinder with a water sample up to 25 ml line. Next, prepare a blank sample by filling another mixing cylinder with 20 ml of deionized water. Add 3 drops of mineral destabilizer into each cylinder. Place the stopper on both cylinders and invert gently several times to mix. Now add 3 drops of polyvinyl alcohol dispersing agent to each mixing cylinder. Again, stopper the cylinder and invert them several times to mix thoroughly. Use a pipette to add 1 ml of Nestle reagent into each cylinder. Pour 10 ml of a water sample into clean sample cell and then pour another 10 ml of blank sample into another clean sample cell. Immediately after that, start a 1-minute timer to allow the color to develop. Turn on the spectrophotometer and select program 380N ammonia nest. When the 1-minute timer ends, clean the blank cell, insert it into the cell cylinder and press 0. The display should now show 0.00 mg per liter NH3N. Now put another water sample into the spectrophotometer, press read, and the result will appear in milligram per liter of ammonia nitrogen. And that's how you perform the Nessler method for ammonia testing. Thank you for watching and always follow lab safety protocols during your experiments.